Welcome to AppSec Village DEF CON Safe Mode 2020. This talk is Web Threat Hunting. It's a background talk for the Web Shell and Threat Hunting seminar that will be coming up later today. My name is Joe Schottman. I had three audiences in mind when I started putting this together. One is for Blue Team members who are looking to learn more about how to understand web-specific threats. Another is for Red Team / AppSec testing teams that want to better understand the traces they leave behind when they're doing an engagement. And most importantly, those who are interested in cross-collaboration. I've never actually formally had incident response as part of my job duties, but coming from a background where I've done both blue team and offensive security work, as well as developing web applications, I've gotten pulled in as a subject matter expert to help better understand what's going on in some cases. It's designed as a background for the people who are doing the 2-hour seminar later this afternoon, but this is also a standalone course, so if you just want to learn a little bit more about it. A little bit about me: I'm a senior security analyst for Truist, formerly BB&T. I've done pretty much everything in IT and security at some point or other. I am a bit enterprisey. I tend to work for very large organizations that have many tens of thousands or millions of users and many systems that will span a wide variety of technology from cutting edge to very, very old. So I tend to think in terms of a wide attack surface and a little bit behind the curve on technology. If you're working with a really advanced team, some of this may not apply as much to you, but most of it will hold true. The obligatory disclaimer: I am not speaking on behalf of Truist, BB&T, or any other entity. All opinions expressed are my own. I saw this quote on Twitter last year from Grifter, who many of you may know from Black Hat or DEF CON. A lot of the things that you'll find on things like Wikipedia defining threat hunting talks about using dark arts and being able to delve into things that normal technology can't do. And I don't really agree with that sentiment. And I thought that Grifter's statement was a good one on it. It's more about understanding what's going on and being able to pick out what's not normal. And it may be something that a normal security tool surfaces to you, but just doesn't have full understanding of what's going on yet, that the human interaction adds what's needed. I also like this definition from Robert M. Lee and Robert T. Lee, that it's about searching out and understanding what people are doing inside your network. Again, it's not focused on having the cutting edge tools or techniques. It's just about understanding what's going on and delving deeper and deeper iteratively. The clever statement that I've seen is, if you don't know normal, you'll get in trouble. The alternative instead is to know normal. The biggest takeaway that I'd like you to get from this is to read your logs and analyze them often so that you understand what's in them and have a good baseline. As you do this, you will often find visibility gaps, and doing this on a regular basis will give you the ability to get some of those gaps closed. This may just be because logs aren't getting sent to your server at all, or it may be because the developers didn't include as much information as necessary. So in those cases, you may need to work with a development team to make sure that they add additional logging capabilities to cover that. There's little worse than being in the middle of an active incident and having to tell management that you don't know what the logs say, where they are, or how to find them, or that the information is flat out missing. How does web threat hunting differ from standard threat hunting? Basically, if you have a public site on the internet, you're being attacked. It may just be low-level attacks from script kiddies and bots, but there's going to be some kind of malicious activity at all times. Standard threat hunting in a mature environment starts with the premise that you have a hopefully more or less secure environment, and almost everything that's going on is just standard day-to-day operations. It's looking for things that are not normal within that indicates malicious activity. Web threat hunting, because there is always going to be some level of malicious activity, involves taking the output from the various tools that provide information about that and filtering out what's just noise and starting to look for the things that might be interesting. A lot of the time you can do the threat hunting using things that are defined as security tools, things like web application firewalls and SIMs, but in other cases you may have to delve in manually and start looking for things by hand within logs and looking for other indicators of compromise. Threat hunting in the web context is the last line of defense. This is kind of the opposite of pushing left. There's a big push in the industry right now to start moving security more and more to the left-hand side of the development process, where you're working with developers, you're integrating security tools into the CI pipeline, that sort of thing. As it flows towards the right, there's things like DAST testing and pre-production and in some cases production traffic. Threat hunting is all the way on the right-hand side before you have a major incident. There's something that is going on if you find something, but you might have an opportunity to disrupt the attacker before something truly bad happens. Just because an application has been compromised doesn't mean that there's actually a serious result that's happened. There are some attackers who are just curious and are looking to find vulnerabilities. There are some attackers that might simply quickly land and do some kind of defacement and accomplish their goal right away. But in general, they're going to have to spend a little bit of time working to figure out what's on the system, what's of value, and what they want to do with it. They may start plundering what's on the system itself, or they might start looking inside the system. But as long as you're spending the time doing that, that's where the threat hunting comes in and gives you the ability to disrupt that. Threat hunting can be the difference between telling the manager that you had a breach and ending up on the front page news as having been breached and having had millions of people's personal information stolen, or having your highly sensitive data going off to a competitor. There's an old truism that I've been seeing flipped a lot in different talks recently, and for ages people have said that the defense only has to mess up once for the offense to get in. At the same time, the offense only has to mess up once for the defense to find them. Attacks don't generally happen instantaneously. There's chains of different things that happen that are explored in concepts like the MITRE ATT&CK framework. If you can find them before they actually accomplish their goal, then you may have had that one mistake that let them get in, but they've had that one mistake that lets you disrupt it before they accomplish their goal. A lot of this is finding digital needles. There's a giant haystack of information about web traffic information that goes on, and you'll see lots of little glints of stuff that might be interesting. Many times it's going to turn out to be nothing, either that it's a low-level attack that just is put on by someone that's not worth caring about. It's like someone who's running a WordPress scraper or a WordPress attack tool against your enterprise that doesn't have any WordPress, or it's just going to be false positive. But periodically, you're going to see something that glints and pick it up and find something really interesting. Data enrichment tools such as SIMs can really help with this. Once you start finding that one little thing that you want to find, like it's an interesting IP that's doing something odd, being able to just click there and have it automatically pull information about where that IP is, what else it's done recently, that will save you a lot of manual time hunting. So if you want to get good at this and you want your organization to be proficient, having a well-developed SIM is really going to be key. Threading the needle, once you start picking up that needle, you'll start finding the thread. The incident IOC, the incident of compromise, may be detected at any point in the attack. You might pick up them doing reconnaissance and be able to stop it really early. You might find them in the middle of compromising a system but not actually being able to do anything on it yet. You might actually find that they've been on the system and they've started already pivoting into your internal systems, and at that point you're not just threat hunting, or you're not just web threat hunting, you're doing full-fledged incident response. When you find that needle, don't necessarily assume that you're at the start of a compromise. You need to work backwards. Similarly, work forwards, think about what they might have started doing after they did whatever you found. Sometimes you'll think that you're at the initial point of compromise, and then as you dig deeper, you might find out that they've actually been doing things for days, weeks, months before you've detected this. So always assume that there could be something bigger than what you've just found. Web threat hunting is mostly log analysis. There's a number of sources that you'll be looking at information from. A big one is WAFs, Web Application Firewalls. That's a context-specific application firewall that is configured to know about web attacks and looks for them in deeper ways than most IDS, IPS systems can. You might be going through a next-generation firewall that has some ability to do basically the same thing as a WAF. They may or may not be configured as sophisticatedly as a full-fledged WAF that's designed to be looking at applications. But you can get some really useful information out of them. It may be going through the IDS or IPS. This is going to be less useful than the previous two, in part because the traffic may not be readable by them. Depending on your strategy for working with TLS at your border, they may not actually have visibility. It may just be encrypted data going from the customer or a potential attacker to your web server, so the IDS, IPS won't have any visibility into this. Increasingly, APIs are used. You may have an API gateway or broker. That's a public front end for your API that takes and aggregates all the requests for different APIs and sends it to the responsible application server. Many of them have WAF type capabilities also, and they can start flagging for unusual data that's coming into the APIs. The application web servers themselves obviously generate a lot of logs. And going back to what I was saying earlier, this is one place where you may find that if you start looking for information, you're not getting everything logged that you need, and you may need to work with the developers to make sure they add all the necessary information. All this tends hopefully flows to a SIM or other log analysis tools. In some cases, you might have multiple SIMs You might have a primary one that's an expensive one that costs per megabyte or data put into it. So you might aggregate to a free one such as the ELK stack and then send information from that on. You might have the concept of a data lake where there's different tools that are able to look at it. But in general, most people are going to be using a SIM or a few SIMs to be doing this type of analysis. Sometimes the indicator of compromise comes from elsewhere. There could be file system analysis needed if malware is uploaded to the system. That's what I'll be talking about later with the web shell threat hunting specifically. There could be PCAP analysis of the malicious activities and non-log traffic. If you're working in an organization that has the ability to store all of its web traffic for a couple days with something like a Gigamon, things like post variables are not commonly logged. But if you can detect an application's attack early enough, you can go and pull out the full web traffic from the PCAP tools and do the analysis on it there and find the traffic that was not logged but is malicious in the posts. Standard endpoint anomaly tools can also detect some of the web attacks. If the attacker is doing something that causes a large amount of file system space to be used or causes the web server itself to start attacking other systems on the network, standard defenses can flag that. It's a little different than what I'm going to be talking about now, but sometimes it will inform other web threat hunting. Tuning is important. It's really important to start finding the false positives and tuning them out of your systems during lulls when there's not actually malicious activity that you care about going on. It's also important to mute things that are malicious but not important. So for example, like I talked about earlier, you're always going to have a certain level of bot activity that's going to be attempting very silly attacks on you that has no chances of getting through. Having some visibility into that in case they start doing something a little bit more clever is useful, so you don't want to filter them out of the logs entirely, but you want to make sure that that sort of thing is not generating alerts that's going to distract you or the SOC staff in general so that you can pay attention to what really matters. Removing the noise allows you to focus on the actual signal, the things that you should be spending the time analyzing and determining whether it's actually a true, false, positive, etc. I'm throwing this in part just because I love the fact that the proper name for this is the table of confusion. There's 4 things that you're going to encounter with different types of alerts. You're going to have a certain amount of true positives. This is obviously the goal for tuning your system to have as many true positives for actual attacks as possible. You're going to have some false negatives, things that slip through your detection systems and are not caught by anything other than possibly human analysis. But mostly you're going to have a lot of false positives, traffic that's benign but is inadvertently labeled as malicious, and a lot of true negatives, traffic that is benign and is not actually detected or labeled as an attack. That's all your legitimate customer traffic and that kind of thing. You're going to have a lot of false positives. Especially on the WAFs, it's very hard to write a generic rule set that's going to be really accurate for all of the different possible applications that it's designed to defend. When you're designing a generic WAF, you don't know what application servers are going to be behind it. You don't know what databases are going to be behind it. So you have to write really generic rules that kind of try to catch a lot of things, but are not going to really succeed. The tuning to remove the false positives will help you focus on what matters, and also creating really specific rules that are related to your environment and your application specifically is what's going to make your WAF and other detection systems really effective. As an example of some sloppy matching within a WAF rule. This is a base 64 encoded value. If you look at the highlighted red parts, there's an O followed by a capital N, followed by a bunch of alphanumeric characters, followed by an equal sign. And I'm seeing a WAF rule that basically comes down to a regular expression that looks for any O case insensitive, followed by any case insensitive, followed by any number of alphanumeric characters, followed by an equal sign. And this is a rule trying to look for on load or similar events within JavaScript, but it's written such that it doesn't actually match the defined on events within JavaScript. It just tries to match any possibility. But when you're working at scale with base 64 encoded values, things like a session cookie might be base 64 encoded like this. When you have a lot of entries, at some point you're going to hit O followed by N, followed by the characters, followed by equal sign. That's just the nature of base 64. So you have a rule that's either going to generate a ton of false positives and distract your analysts, or you're going to have a rule that's so bad that you just turn it off. So finding things like this and removing them and tuning it and putting in better rules is key. There's some things that are really convenient for developers but create pain for operations that I've seen. Developers can create false positives for SQL injection and that kind of thing by using languages used by SQL within the APIs. It's perfectly legitimate, and it makes sense when you want to be able to look at the API calls and see what it's doing. But when there's a API call that uses a keyword like update, delete, or order, you're going to get some false positives saying that it's detective SQL injection. So figuring out ways to tune the system or work with the developers to see if they can use different terminology or set it up in such a way that it won't trigger these false positives will make your life better. There's a number of sources of There's a number of things that will trigger web threat hunting. You might have alerts coming in that are generated by security tools that will cause you to start digging deeper. These are your WAFs, your firewalls, etc. You might be doing data mining on your information and have it looking for interesting patterns. So if you have a single IP that's going to only a few IP, you're going to have a number of sources that will You're going to have a number of sources that will trigger web threat hunting. You might have alerts coming in generated by security tools such as WAFs or firewalls that will cause you to start digging deeper. You might be doing data mining on your web traffic, looking for unusual things like a URI that's being requested by a single IP address. You might have known vulnerabilities that you say, oh, we had the F5 announcement earlier in July that caused There's a number of things that will trigger web threat hunting. You might be getting alerts from things like your security tools, your WAFs, your IDSs that will trigger you to start digging deeper and looking to see if there's something going on. You might be doing data mining on all your web traffic, looking for unusual patterns. So this could be looking for things like a URI that's only requested by a single IP address, and you might see if there's a reason why that's happening. There might be known vulnerabilities. For example, in July of this year, F5 had a major vulnerability that was relatively easy to exploit. So you might start, once that's disclosed, go in and start seeing if someone discovered it previous to the announcement and start hunting and looking to see if there might have been a compromise. You might get a threat intel feed that says, hey, we know that there's going to be this specific attacker looking at you based on dark web chatter, and so you might start doing threat hunting based on that. You might have situational awareness, just keeping an eye on your crown jewels, your really important information. This is where some of the human intuition and understanding how the application works, looking for an unusual pattern comes in. You might have honey traps. For example, some people put information into the application that only a bot would follow, or something like robots.txt that similarly no human would ever have a reason to go to, but anyone going to it looks suspicious. This can be a double-edged sword because a lot of the traffic going to these is going to be something that is very low-level attacker that's not very sophisticated or complex. You can spend a lot of time chasing things that don't matter, but it's sometimes worth doing. There could be feedback from operations that they don't know exactly what's going on, but they notice that something's odd with the system, so you might start investigating the web traffic to and from it to see if there's something going on. And just random hunches, like I mentioned with the crown jewels, sometimes something just doesn't feel right, or there might be a pattern that you read about and start looking around, digging around to see if you're seeing inside your environment. As an aside, I recommend getting good with regular expressions if you want to do threat hunting. They're invaluable for many types of security work. Most major security tools that I work with have some use of Regex at some point. If you're not familiar with them, they're a language or a format for describing characters in a sequence. If you've never seen it, Regex Golf is a fun way to learn and practice. The link is alf.news/regexgolf. I go through every year or two and replay it and find that I relearn things that I've forgotten. It will teach you some really powerful and unusual thing to do with regular expressions. I threw in the illustration of the cat because regular expressions often look like an animal sat on top of your keyboard, as illustrated by the link, or the regular expression I have for index or test.php at the bottom on different servers. One really important regular expression tip, if you're not used to working with them and you're going to start working with them in a sim where there's a lot of data, they're pretty computationally expensive. Putting the caret sign at the beginning of the regular expression anchors the pattern that follows it to the beginning of the string, and putting a $sign at the end of the regular expression anchors it to the end. If you have the ability to know that something's going to appear at either the beginning and or the end of a regular expression and can do that, it will save a lot of computing power and make your SIM administrator a lot happier with you. As an anchor example, if you've got a string that is 1A234 blah blah blah, if you use a simple regular expression that is 1 followed by either A or C, it only takes 2 comparisons to match, and at that point the regular expression engine will short circuit. But if you have 1 followed by D or F, it takes 21 searches to fail because it has to go through and look at each one of the possible pairs there. But if you happen to know that the 1 has to be at the beginning of the string followed by D or F, it's not going to match, but it only takes 3 attempts to fail. So keep this in mind if possible, and use as tight and concise regular expressions as possible when you're working with enterprise scale data. Some of the common HTTP headers to examine. The very obvious common ones are the get and post variables. This is where people are often going to be trying to use things like cross-site scripting attacks, SQL injection, command injection, etc. Examining the user agent can be useful. In some cases, their automated tools are going to use a really old user agent. So at a certain point, when you upgrade it to modern TLS suites that are safe, IE6 literally cannot connect to your site because it won't support any of the supported ciphers. So at that point, if you have upgraded to a modern TLS suite and you ever see IE actually connecting to your system, you know that you're talking to something that's not actually Internet Explorer. You can also look for things like languages. Some attackers who are not in the same country as you may still have the user agent of whatever their native language is, and you can use that to signal that it's unusual traffic if you don't tend to do a lot of international traffic. The refer header is something that's really common to look at. In some cases, bots will not have it at all. Most human web traffic will have a refer header of some kind, unless it's landing for something. If it's landing on you from a secured page using HTTPS that links to you, you're not going to get a refer header. But anything deep inside your system that they're coming in linked from parts of your system, you're going to have a refer header. And cookies will also have a lot of information. Again, they're going to be trying things like SQL injection attacks or cross-site scripting attacks in these. So that's another common thing to examine. But you also need to keep an open mind and have a system that's capable of examining other headers. For example, in 2017, there was CVE 2017-5634, the major struts 2 vulnerability in March. And initially, this was a very simple attack where you could just put basically Java code in the content type header and it would execute. Very simple to execute and relatively easy to detect. But if your tooling wasn't set up to examine the content type header, then you had to make sure that you could scramble and get that done. However, they also revised the information later and found that both the content disposition and the content length headers were theoretically vulnerable as well. So if you were only putting in detection and mitigation on the content type header, you had additional exposure there. Sometimes API developers get creative. API first is taking over the industry, where rather than having a website that talks to a server in a specific way and having an API that might talk to it in a different way, they're building a common API and using a website that calls that same API as what your mobile application might be calling. In some cases, they might be adding custom API headers that your tools are not even aware exist, and that creates an attack surface. Or they might be misusing a common HTTP header in a way that's unusual that your tooling may not be examining because you don't expect that it would be anything that would ever be going to a database engine. And so just be aware of what your API developers are using. Try to keep them using the common standard definitions rather than doing something creative. X404 is another important header to be aware of when doing web threat hunting. In the early days of the web, the IP address that a web server would record as having talked to it would be the actual client IP because it was a simple client-server interface. As things got more complex with things like proxies and content distribution networks, the only information that the server was able to record is what actually talked to it, not the client itself, and there was no way of validating where it came from. The X404 header was an attempt to solve this, and it solves for it operationally, but not in a security manner. Basically, from left to right is the actual client followed by every jump that it took that terminated the connection and talked to something else. So that could be, in this case, 192.168.0.5 talked to a content distribution network at 10.100.20.123, which talked to a load balancer at 10.100.3.76. What your application server would record as having talked to it would be the 10.100.3.76, but that would be true of all content coming in because everything coming in would be from that load balancer. In some cases, people will use that far left value and log it as the IP that connected to it, but that's not accurate because it's all about trust. Only the rightmost entry can be trusted. Anything other than that could have been forged by an attacker. So in some cases, people might have whitelisted a 10.10 address in their application and used this header to to validate whether someone was coming from their internal network or not. If an attacker puts a 10.10 address as the client value and makes a connection to whatever's letting them into your network, the actual client IP address is going to show up as if it was proxy 1, and the client address will reflect their forged 10.10 address. So never actually trust this value. It's useful for seeing where the data probably flowed through, but not necessarily accurate. Akamai and other CDNs have the ability to send you a special header that is what they actually talk to. So if you're using Akamai, make sure that you've configured it to use the true client IP, which will be guaranteed to be accurate as far as what's talking to them, although an attacker may be proxying through other systems, but not web proxies. When I say proxying through other systems, I mean they may have compromised systems and are using a botnet to proxy all traffic, but that will be the actual IP that's making the connection to Akamai. And that's as far back as you're going to be accurately trace. So make sure that when you're logging and looking for IPs, something like the true client IP is what's under consideration. There's 5 main classes of HTTP responses, 3 of which have common implications for web threatening. There's the 1XX ones, that's informational. I don't typically see them in my day-to-day work, although I've definitely seen some cases where they show up. 200 is what you're supposed to be getting a lot of the time, that's successes. There's not generally a lot of threatening that you'll get in this, but in the case of SQL injection, a 200 response can be dangerous. I'll talk a little bit more about that in a moment. 300 is just redirection. There's not typically a lot of threats that are found in this. The 400 is client errors. It's an indication that something went wrong with the request that's being made to the server. Sometimes you'll find interesting things within that. And 500 is server errors. That's something that the client sent or something going on in the server went wrong and the server was unable to handle the request. And a lot of threat hunting will be found in that. The 400 errors, the 400 is a bad request. That's a malformed request was sent. Oftentimes I've seen this from fuzzers or poorly written tools, or in some cases just typos. So this may be kind of noisy, but you can find some interesting things with that. The 401 is unauthorized. It means that the server is configured to require authentication to talk to it, and they have not in some way satisfied that. So this can be indicative of things like brute force attacking that you might want to be aware of, or credential stuffing. 403 is forbidden. It's a valid request, but the server will not satisfy it. This can be, again, signs that something is scanning your system and getting turned down, and can be a sign that something, and 400 errors are indicative that there's something incorrect about the request itself. A 400 error is a malformed request that is missing something or malformed. I've seen it from fuzzers throwing complete garbage at web servers trying to get them to fall over. I've seen poorly written tools that did things like forgot to include a required header, and I've also seen typos in manual testing causing this. A 401 unauthorized means that the server is requiring authentication and that they're not providing it. This is an important one to be aware of for things like credential validation attacks, credential stuffing attacks, and also just trying to gain access to parts of a website that an attacker is not supposed to be able to get access to. 403 forbidden means the request is properly formatted, but that the web server is not going to allow access. So they may have a proper authentication header, but that account may not have access to that part of the website or the file they're trying to access, and that will cause this. So getting a lot of these can be indicative of an attack. 404 doesn't typically show up a lot within or in a useful way in threat hunting. And 405, a method not allowed, again, not very common within web threat hunting as far as finding useful information, but occasionally you'll find things like with API attacks. 500 errors means that there's attack on the server itself. A 500 error is a generic error. Very often attack tools will cause a server error. So if there's a SQL injection attack and the SQL injection attack is partially working, but they don't have properly formed SQL that will work, that will generate a 500 error. A sudden spike in 500 errors is something to be very aware of, and it may not be indicative of an attack, it may just be a software bug, but these are not things that should commonly be going on in a well-written web application, so they should be flagged and addressed in some fashion. The others are commonly caused by proxy issues, and you'll see them from time to time doing this type of threat hunting, but really it's the 500s that you're paying attention to. A problem I've observed is what I think of as the 1=1 problem. Many tools don't provide a lot of context on the alerts. They might have a link to a generic write-up of the description of the type of attack, but they may not give the context of why it looks like the attack succeeded or failed, and it doesn't provide the context of why an attacker might be doing it. Many tools rely on simple pattern matching rather than a deeper understanding, so you can get false positives, and an analyst that doesn't know how systems operate may not be able to easily tell that it's a false positive. As an industry where we often don't provide the training that junior analysts need, I started thinking about this because people would often ask me, are we vulnerable to the 1=1 attack? Because they were getting these alerts from the SIM saying that there was a SQL injection attack. But what they could see in the alert itself was that there was 1=1, and that was getting flagged as malicious. And they didn't have the context of knowing that it was SQL injection, what SQL injection does, and why it's important. There's also the information that's critical to understanding of whether the attack succeeded or not. And a SQL injection attack that has where there's a vulnerability, where there's a 200 response, is a lot more dangerous than one where there's a 500 response. If you're going to do this type of work, building an understanding of how web applications work and what the different response codes mean, what different technologies are and do, is really important. Another thing to be aware of is who is targeting you. Situational awareness on who might target you and why is important. So you're always going to have a certain level of internet bots attacking you and script kiddies just randomly. There are ransomware groups that might be basically targeting anyone on the internet. But if there's something interesting about you, if you're a defense contractor, if you're a hospital, if you're a financial institution, if you're an educational institution, you're going to have some very specific groups targeting you with very specific goals in mind. And understanding who they are and what they're going to be trying to do will help you build better defenses to detect attacks that they're conducting, as well as to defend yourself. It will also affect how much time you spend on hunting and what you look for. If you're a small company that doesn't have a lot of internet presence and there's a very small attack surface, there's not a lot of point in you spending expensive man hours trying to defend a website. Whereas if you're a widespread educational institution with thousands of different websites online, you're going to have a much different approach to how you need to keep an eye on what's attacking your network. I said generally you should try to be using some kind of SIM or other data complex analysis tool, but I'm going to mention a few tools that if you're not familiar with them are really useful for when you have to dive in and just work with raw log data at various points. Grep is a tool that's used for searching for text strings. It's one of the most common things that you'll use for doing threat hunting. Set is very useful for manipulating data. Awk is useful for taking different columns and formatting them different ways. There's a number of things that it can be used for, but that's my most common use. One handy thing that Awk is useful for is that you can specify delineator that is really useful for handling how Apache logs are formatted in a way that something that is based on white space doesn't work. Sort is obviously something that you use to sort the information, but there's a few different flags that you might want to be aware of for that. Unique takes a ordered list and condenses it down. That's really useful for getting like counts of how many times a IP has contacted you, or counts of how many times a URI has been accessed. WC will give you that actual count if you're not using sort, or if you're not using unique for that. And head/tail is useful for information, cutting down the information that you're looking at any given time. So if you're not familiar with all of those tools and you want to be doing threat hunting, I'd suggest taking a quick look at how each of those might be used. What to do when you actually find something when threat hunting. Assuming it's part of your area's responsibility, you need to classify the threat. It might be noise/background chatter, so it might be something that you've not really seen before, but it's not been tuned out by the logs. But ultimately, you determine it's just a bot or script kiddie doing something that doesn't affect your attack surface. It might be something malicious but unimportant. So this would be an example of something that you want to keep visibility into, but make sure that it doesn't trigger alerts. So if you're an entirely Java shop and someone's doing a C# attack against you, but being fairly clever in it, and it's not just an automated tool, you might want to be aware of them in case they get smarter and switch up to a Java-based attack, but you don't have to spend a lot of time analyzing them otherwise. It might be an actual incident. This may be where it shifts from your area of responsibility to an incident response team, where you conclude that they've actually done something significant to the system. You need to start looking at doing things like forensics and starting to look to see if the system is compromised and if they've started going deeper into your network using it, or if they've done something like exfiltrated important data that was on it. And like I've mentioned a couple times, you might have actually just uncovered a software bug, in which case you need to file a defect report with the developer or whatever company you bought the software from. Wrapping up, the takeaways from this is please know where your logs are, understand what's in them, and know how to search for them. Make sure that if you find that there's a log that you need and it's not in that repository, that it gets added to it. If you don't have a sophisticated search tool of some kind, even if it's just something free like the elk stack, try to get one and make sure that it has all the data in it. One thing that's important is if you have a large environment that has test systems, ideally you need to have the test information flowing to them also. Attackers often, if they start pivoting around on an internal system, or start looking for test systems because they're not as well patched, and oftentimes their logs are not going to the main SIM, so attacks on them could go unnoticed. So you want to make sure that you have a single pane of glass where you can search for attacks for everything within your network if possible. If you don't have a WAF, Web Application Firewall, consider getting one. They're not a panacea, but one thing that's really useful for them is just cutting down on the noise. I use the analogy that they're the bouncer on the external part of your network, keeping the obvious riffraff out. If you use them to bounce the script kiddies and the bots in such a way that it's logged but not going to your alert system, that will cut down on your work tremendously. They do actually, they will not prevent all attacks, obviously, but a well-configured one can prevent a lot of incidents. If you are deploying WAF for the first time, or if you have one and haven't validated it, one thing that's really important is to make sure that's not bypassable. A common mistake is using a cloud WAF where the traffic is going through the cloud provider talks to your system. If you don't use firewalls to block off that system to make sure that only Akamai or the other cloud providers are the ones talking to it, someone can connect directly to that IP address and bypass the WAF protections and WAF visibility. So make sure that there's no direct connections that aren't authorized allowed. Know what's normal. On a day-to-day basis, be aware of what goes on in your environment so that you don't panic over something that's not malicious. Tune your systems as you find visibility gaps, as you find false positives. Do what you can to start eliminating them so that it cuts down on the work for yourself down the line. As much as possible, try to understand the attacks and what's going on with them rather than simply relying on pattern matching. Understand why a SQL injection attack may or may not work on a system. If you see signs of SQL injection attack on something that's exclusively using a NoSQL database, then there's a whole lot less concern about it. It's something that you might want to flag as suspicious and malicious, but you don't necessarily need to dive deep on it. And be aware of who's trying to attack you and why. If you're in a major organization that has a legitimate APT-style attacker targeting you, try to be aware of who they are, what tools they commonly use, and things like that. Thank you for the time, and let me know if you have any questions. Thanks.